Now let's move on to the next topic, which is quadratic equations. A quadratic equation is an equation of the form ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers with a is not equal to 0. So first we have the zero product property. We have ab is equal to 0 if and only if a equals 0 or b equals 0. So let's try to solving a quadratic equation by factoring. So factoring, we discussed that one in the previous chapter. So let's try to apply again your knowledge about that. So let's try first for letter A. For letter A, I will write it here below. We have x squared minus 3x is equal to 0. To solve for that, we are going to apply the common monomial factor. So our common factor is x, so therefore x times x squared. We are going to divide first x squared minus 3x by the common monomial factor. So let's start in the first term. X squared divided by x is x. Negative 3x divided by x is negative 3 is equal to 0. Now, the factors of x squared minus 3x are x and x minus 3. Then, you equate now each factors to 0. So we have the first factor is x is equal to 0, and the other one here x minus 3. So we have x minus 3 equals 0. So this one is now the first answer. And this one we need to solve for x to transpose negative 3 to the right hand side. Therefore, x equals 3. So that there are two answers now. We have x equals 0 and x minus 3. Now for letter B, we have x squared plus x minus 6 equal to 0. So I will write first x squared plus x minus 6 is equal to 0. Now, we're gonna factor negative 6. So do you remember my strategy for solving for that? Let us recall, we are going to find the factors of negative 6 that will give you a sum of the factors of positive 1. So I would choose now positive 3 and negative 2. 3 times negative 2 is negative 6, but if you're going to add that, we have positive 1. So the factors now will be written as x plus 3 times x minus 2 is equal to 0. And then equate now each factor to 0. So we can write here x plus 3 is equal to 0, and the other one is x minus 2 is equal to 0. So equate now to solve for x. So we have x is equal to 0 minus 3 is negative 3, and this one is x transpose. It becomes now 0 plus 2 equals 2. So the value of x now are negative 3 and x equals 2. Okay, now for letter C, I will just write it here on top. We have 4x squared minus 9 is equal to 0. In that case, I cannot easily factor 4 and 9. What I'm going to do with that is I'm going to transpose negative 9 on the right-hand side. And that will become 4x squared equals 9. And then I'm going to divide both sides by 4. So dividing this by 4, then we have now x squared is equal to 9 over 4. And solving for x, we have now the answer plus and minus. The square root of, we are going to take the square. To solve for x, we need to take the square root of this. So square root of the x squared equals the square root of 9 over 4. But when we take the square root of this, there are two possible answers, either positive and negative or both. But you need to check which one is the correct answer. So in this case, the square root of 9 over 4 is 3 halves. So that there are two answers there, positive 3 halves, and the other one is negative 3 halves. Now for letter D, so we have 3x squared plus 5x plus 2 is equal to 0. So do you remember the way I solved on the previous chapter? I'm going to use the AC test. So the value of A here equals 3 and the value of C equals positive 2. So the product of this, when you multiply, we have AC is equal to 6. Now, we are going to find the factors of AC that is now 6 that will give you a sum of 5. Is it possible? So factors of 6 that will give you the sum of 5, shall I say 3 and 2 is 3 times 2 is 6 and 3 plus 2 is 5. So we are going to, the factors of 6 now is 3 and 2. When you multiply, we have 3 times 2 equals 6. But if we are going to add, we have 3 plus 2 equals 5. Wherein this 5 can be seen on the middle term. Now, therefore, that factors are correct. But the value of A is greater than 1. So when A is greater than 1, then we are going to divide both sides by 3. So I'm going to divide by the value of A. So this will be divided by 3 and this will be divided by 3. And this is now equals to 1 and this one equals to 3. So these are the factors that I'm going to use. So we are going now to write the factors. So we can write now here, since it's only 1, so I will write here x. x plus x plus 1 times, since this is a fraction form, the coefficient of your x now is coming from the denominator, which is now 3. Therefore, it becomes now 3x plus 2 is equal to 0. Now, you try to counter check your factors if that will give you to the original given. Now, let's try to check using the FOIL method. So, x times 3x is 3x squared. Outer terms, we have x times 2 is 2x. Inner terms is 1 times 3x is 3x. So add the outer and the inner terms, we give you 5x. And the last term is 1 times 2 is 2. Therefore, the factors are now correct. Now, after that, we want to know the value of x. So therefore, equate each factor to 0. So we have x plus 1 is equal to 0. And the other one is 3x plus 2 equals 0. Solving for x, in this side, we have now x equals negative 1 because 0 minus 1 is negative 1. And this one becomes 3x equals negative 2 transpose. That's why negative 2. And divide both sides by 3. Therefore, dividing this by 3, therefore, we have now x equals negative 2 thirds. So, I hope you were able to follow it well. Next, we have find the solution set S of each equation by using the square root method. So the square root method is similar to what I give you here. That is on letter C. Okay, for letter A, I will write now. A, we have x squared equals 4. So using the square root method, we're going now to take the roots of both sides. We take the square root of both sides. So square root of x squared is equal to the square root of 4. This is now cancelled. The exponent of 2 and the radical sign, or we have, because the index there is 2, so 2 over 2 equals 1. So therefore, x now is equal to plus and minus. The square root of 4 is 2, therefore plus and minus 2. So these are the two possible answers. We have x equals positive 2 and the other one is negative 2. Now for letter B, we have, they're almost the same. So we have x squared equals 25. So take the square root of that. Then x now is equal to plus and minus the square root of 25. So x equals now plus and minus square root of 25 is 5. Now for letter C, we have the quantity of x plus 1 squared equals 4. Taking the roots, we take the square root of this and we take the square root of 4. Therefore, 2 there will be cancelled. I have x plus 1 equals plus and minus the square root of 4. All right, and then we will solve this first. We have x plus 1 equals plus and minus 2. So transpose, to solve for x, we have x equals negative 1 plus and minus 2. So if we're going to separate the two answers, I will say x sub 1 equals negative 1 plus 2. And for the x sub 2, we have negative 1 minus 2. We have to simplify further this side. First, the value of x sub 1. So I have x sub 1 now equals negative 1 plus 2 is 1. That's now the first answer. And for this, I have x sub 2 equals negative 1 minus 2 is negative 3. So the two possible answers now of x is 1 and negative 3. So for letter D, so you do the same procedure. For letter C, I have letter D here. We have the quantity of 2x minus 1 squared equals 9. So taking the square root of this, we have 2x minus 1 squared equals the square root of 9. So this will be cancelled, cancelled. So I have 2x minus 1 equals square root of 9 is plus and minus 3. Transpose the constant term to combine the other side. We have now 2x equals, transpose, it becomes 1 plus and minus 3. Let us try to divide first by the coefficient of x. So divide both sides by 2. So therefore it becomes now x equals 1 plus and minus 3 all over 2. I did not show anymore dividing by 2, but I said you have to divide both sides by 2. Therefore the result is x equals 1 plus and minus 3 all over 2. So in the same manner, I will write now x sub 1 and x sub 2 to differentiate the two answers or to separate the answers from the value of x. So we have x sub 1 is equal to 1 plus 3 equals 4 over 2, or that is now positive 2. For the x sub 2, we have 1 minus 3 is negative 2 over 2, that is equal to negative 1. So the two possible answers there are 2 and negative 1. Okay, so the next we have here is solve the equations by completing the square. So this problem is we are asked to solve the equations by completing the square. So in solving the equations using completing the square is that first of all, you are going to find the value of b. If the value of a equals 1, just like in the example letter A. So our a there is x squared plus 6x equals 0. So when a is equal to 1, then our solution will be first find the value of b. So find the value of b and then divide, always divide by 2. So right there, b divided by 2. Whatever the answer will be raised to the second power, and the result of this will be the number to be added in both sides of the equations. Now, for example, letter A, I have x squared plus 6x is equal to 0. So A there is 1, so we just follow this formula. We have to find right away the value of b and then divide by 2. So the value of b there is 6, so therefore 6 divided by 2 equals 3. Then whatever the quotient will be raised to the second power, and 3 squared is equal to 9. And this is now the number to be added. So I will write now as x squared plus 6x plus 9 is equal to 9. So this is the number that we added in both sides of the equation. Because if you're going to transpose 9 from the right-hand side to the left-hand side, it becomes 9 minus 9 is 0. Therefore, it goes back to the original equation. Now, on the left-hand side, the x squared plus 6x plus 9 is observing the property of the perfect trinomial square or sometimes I call that one as perfect square trinomial, wherein the factor of that becomes a square of binomial by just taking the roots of the first and the last term. So the square root of x squared is x. I use plus because the sign of the middle term is plus. And then the square root of 9 is 3. And then the factor now is x plus 3. The quantity of that will be squared is equal to 9. Then after that, we are going to take the roots. So taking the roots of this, the square root of x plus 3, the square, is equal to the square root of 9. So simplifying, this will be cancelled. The power of 2 and the value of the index of 2. Therefore, the remaining answer is the radicand, which is x plus 3 equals the square root of 9 gives you the answer of plus and minus 3. Now we are going to separate the answers by transposing this one. Let us transpose it first. So we have now x equals from positive 3 becomes negative 3 plus and minus 3. So separate the two answers. I will write x sub 1 equals negative 3 plus 3. So x sub 1 now is equal to 0. And the other one is x sub 2. We have negative 3. I will use now the negative sign. Negative 3, and therefore x sub 2 now equals negative 6. So these are now the two answers for letter A. So for letter B, we have the value of C, which is now negative 3. In our previous example, the value of C here is 0. Now, if the value of C is greater than 0, first of all, you're going to transpose it to the right-hand side. So, following what I have said, this will become now, we have x squared plus 2x. Transpose the value of C on the right-hand side becomes 2x squared plus 2x equals 3. Okay, and then this is now similar to the first example. So follow what I have done here. Find the value of b, which is now 2. Then always divide by 2. So the quotient is 1. Whatever the quotient will be squared. And then the answer of this is the number to be added, which is now 1. So the number to be added now is 1. So I will write the given. I have x squared plus 2x plus 1 equals 3 plus 1. All right. So simplifying this one. So this one now on the left-hand side is a perfect square trinomial. So the whose factor for that is x plus 1. The quantity of this squared equals 4. Now to eliminate the power of 2, we need to take the square root. So taking the square root of this, so we take the square root of this and this side. So therefore, that can be written now as, so this will be cancelled. That one. So therefore, the remaining is the radicand, which is x plus 1, equals the square root of 4 now equals positive and negative 2. So we have to solve for x. So we have to transpose positive 1 on the right side. We have now x equals, I will write here x sub 1 equals negative 1 plus 2. So we have x sub 1 equals positive 1. And the x sub 2 will be negative 1 using the negative sign. So negative 2. So x now equals negative 3. So the two possible answers now are these. We have x minus 1 and x minus 3. Now for letter C, 4x squared minus 4x minus 8 is equal to 0. Since for letter C, the value of A is greater than 1, then first of all, you are going to divide all the terms by the value of A. So therefore, this is I will write it first as ax squared plus bx plus c is equal to 0. If this is the pattern class, then divide all terms by a. So therefore, we have x squared plus b over a of x plus c over a is equal to 0. Because I divide all the terms by a. So ax squared over a is x squared, then b over a of x plus c over a, then 0 over a is still 0. Then that's what I'm going to do it here. So therefore it becomes now 4x squared over 4 minus 4x over 4 minus 8 over 4 is equal to 0. So I am dividing all terms by the coefficient of x squared or the value of a. So simplifying that one, it gives you now the first term of x squared. We have x squared minus 4x over 4 is 1 or 1x or just x minus 2 equals 0. So transpose first the constant term. We have x squared minus x equals 2. And then find the number to be added here on the left-hand side. So the coefficient of x is 1. So therefore 1 then divided by 2. Since the answer is a fraction, then you just square. So the square of 1/2 equals 1/4. This is the number to be added. So I will write now the equation of x squared minus x plus 1/4 equals 2 plus 1/4. So to factor this one, take the roots of the first and the last term because this is a perfect square trinomial. So we have square root of x squared is x minus, I use minus sign because the sign in the middle term is negative, minus the square root of 1/4 is 1/2. So quantity of that will be squared. If you are going to expand this one, so the result will become x squared minus x plus 1/4. So for the right-hand side, we are going to simplify 2 plus 1/4. So this is now 9 over 4. Okay, to remove the power of 2, we have to take the roots. Take the square root of this and the left side and on the right-hand side. So we can write now here as x minus 1/2 when you take the roots is equal to the square root of 9 over 4 is 3/2. Then this is now plus and minus. And then you transpose the negative 1/2. So we have x equals positive 1/2 of plus and minus 3/2. So simplifying this further, I will write here x sub 1. I will use first 1/2 plus 3/2. So I will write it here 1/2 plus 3/2. So this is now, since this is singular fraction, so add the numerator. So 1 plus 3 is 4 over 2 is 4 over 2 means 2. And for x sub 2, we have positive 1/2 minus 3/2. So similar fraction, so denominator of 2. So 1 minus 3 is negative 2 and divide. So we have negative 1. So the two values there is, the possible values there are 2 and negative 1. Okay, now let's continue for letter D. So the given is 9x squared plus 6x minus 24. Take note that we are asked to solve this using completing the square. So first of all, since the value of a is greater than 1, so divide all terms by 9. So 9x squared divided by 9, we have x squared. And 6x divided by 9, we have, I will write for 6x over 9 minus 24 over 9 is equal to 0. And then, or if you can, we can reduce this one. 6 over 9 can be reduced to the lowest term, but I guess it's okay if we're not going to reduce it. And next, we have to transpose the constant terms. I will write first x squared plus 6x over 9 equals 24 over 9 plus 0 still 24 over 9. So we have now here the value of b, which is 6 over 9. So we are going to divide the value of b by 2. So we can write now as 6 over 9 divided by 2, or that can be written as 6 over 9 times 1 half. We take the reciprocal of 2 to change the operation. So we have now the value of b over 2. This becomes now, reducing this one, 6 over 2, we have now 3 over 9. 6 times 1 is 6 over 8. 9 times 2 is 18. Or we can use cancellation. 6 divided by 2, so we have now 3 over 9. So this is now the quotient for b over 2. So whatever the quotient of b over 2, we are going to square. Alright? So since b over 2 is 3 over 9, 3 over 9, let's try to reduce it first. That is now 1/3. So, but 1/3 is the equivalent of 3 over 9. Then take the square. So, squaring that one gives you now 1 over 9. So, this is now the number to be added. So, I will write here. So, from here, I have x squared plus 6x over 9 plus 1 over 9 equals 24 over 9 plus 1 over 9, because the number to be added is 1 over 9. This is the number that we added, 1 over 9. So we take now the roots for the first and the last term. So this is now x, square root of x squared is x plus, because of the middle sign is plus, so square root of 1 over 9 is 1/3. And then we're going to square, and then adding this one, we have 25 over 9. So after that, we take the roots of x plus 1/3 square, and then the square root of this 25 over 9. So this one and that one will be cancelled. So therefore, we have x plus 1/3 equals, the square root of 25 over 9 gives us the answer of plus and minus 5 over 3. Then to solve for the x sub 1, we're going to have transpose becomes negative 1/3 plus 5 over 3. So the x sub 1 now equals negative 1/3 plus 5 over 3. We have 4 over 3. And the other value for x sub 2, we use negative 1/3 minus 5 over 3. So we have negative 6 over 3, or this is now, negative 6 over 3 is negative 2. This is now the value of the other possible value of x. So we have negative 2 and 4 over 3. So the reason why I said possible values, because we need to check first the extraneous roots. But this time, I'm not going to discuss the extraneous roots. So those are yet the possible values of x. So for the last example, we have letter E. We have the given is x squared minus 6x minus 32 is equal to 0. Okay, in this example, so since the value of A is only 1, so no need to divide by 1. So all we have to do first, transpose the constant term. Okay, so the first we are going to transpose negative 32. So we can write now x squared minus 6x equals 32. After we transpose the constant term to the right-hand side, find the value of b. So the value of b there is negative 6. So we can write now, or just write 6. Because we're going to include negative, the square of that negative is always positive. I could say that the value of b now is 6, and then divide by 2, the quotient is 3. Then whatever the quotient, we have to square. The square of 3 is 9. Or if you like to carry the sign, so we can write 6, negative 6 rather. So we have negative 6 over 2 the quotient is -3, then the square of -3 is still 9. So the answer is just the same. Okay, so the number to be added now is 9. So from here, I'm going to write now as x squared minus 6x plus 9 equals 32 plus 9. So factor of this is x minus 3, the quantity of this is squared, and then 32 plus 9 is 41. Okay, so take the roots of this, take the square root of both sides, so x minus 3, the squared, equals the square root of 41. So this is cancelled. So we have now x minus 3 equals plus and minus square root of 41. But 41 has no perfect roots. So just remain the square root of 41. If possible, you just use radical sign instead of decimal numbers. So we have now transposing to -3. So we have x equals 3 plus and minus the square root of 41. Separate the two possible answers. I will write x sub 1 equals 3 plus the square root of 41. And the other one is x sub 2. We have 3 minus the square root of 41. Or, if you like, you can also take the approximate value of the square root of 41, which is now 6.40. So I'll just write here 3 plus 6.40. This one is 3 minus 6.40. So 6.40 is the approximate value of the square root of 41. So this one now will give you the answer of 9.40, and this one is negative 3.40. Okay, so whichever is the answer, it's either this one or this one for the x sub 1. This one also, and for this is for the value of x sub 2. So next is using the quadratic formula. So from the definition, if ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers, and a is not equal to 0, then the formula now, for the quadratic formula, we have x equals negative b plus and minus the square root of b squared minus 4ac all over 2a. So this formula for the roots of a quadratic equation is called the quadratic formula. So the quantity b squared minus 4ac that is inside the radicand is what we call as the discriminant of a quadratic equation. In our solution, we are going to use the symbol of delta. So I use here, it is denoted by delta. Delta equals b squared minus 4ac. We use the discriminant or the symbol of delta to determine the nature of the roots of the quadratic equations. So for a quadratic equation, ax squared plus bx plus c equals 0. So if b squared minus 4ac, or the discriminant, or shall I say delta in our discussion, if delta or the discriminant is greater than 0, there are two unequal real roots. Property number 2, if the discriminant is equal to 0, then there is a double root. That is, there are two identical roots. Now for number 3, if the discriminant or delta is less than 0, then there is no real solution to the equation. If there is no real solution to the equation, and that's what we call as imaginary solutions. So to solve the quadratic equation by using the quadratic formula, so follow the steps. Okay, this is how to derive the formula for quadratic formula. Okay, so write the equation in standard form. We have ax squared plus bx plus c equals 0. Identify the value of a, b, and c. And next, we have to evaluate the discriminant. We are using delta here for the discriminant, which is actually b squared minus 4ac. So as I've said earlier, this is what I have read a while ago on the last slide. So for number 4, if delta or discriminant is greater than or equal to 0, then you have to solve the equation using the quadratic formula. So the quadratic formula that we have read a while ago, so this one is the formula. Okay, so let's try to solve some examples. So we have x squared minus 5x minus 14 is equal to 0. So for this example, let us try to solve this one. Okay, for this problem, our value of a, the value of a there is 1, the value of b is negative 5, and the value of c is negative 14. So I'm using delta is equal to b squared minus 4ac. So solving for delta, our b is negative 5. So we have negative 5 squared minus 4 times the value of a is 1 times the value of c is negative 14. So delta now, we have the square of negative 5 is 25. Negative 4 times 1 times negative 14. So we have positive 56 because negative times negative is positive. So we have positive 56. Then we have 25 plus 56 equals 81. Now, what can you say about the discriminant? So we could say that the discriminant is greater than 0. If delta is greater than 0, then the equation has two real roots. So that is our expected answers. Now let's try to use the quadratic formula, and the outcome should have two real roots. So using the formula now, we have x equals negative b plus and minus the square root of the delta all over 2a. Take note that delta is equal to b squared minus 4ac. So by substitution, we have x equals the negative of the value of b is negative 5 plus and minus the square root of the delta, which is discriminant, that the one that we solved earlier, that is now 81 all over 2 times the value of a is 1. So we have negative of negative 5 is positive 5 plus and minus the square root of 81 is 9. So plus and minus 9 all over 2 because 2 times 1 is 2. So separating the values of x, so I will write right here, x sub 1 equals 5 plus 9 over 2. And the other one is x sub 2, we have 5 minus 9 over 2. So simplifying further, the x sub 1 and the x sub 2, we have 5 plus 9 is 14, divided by 2 is 7. And the other one is, we have 5 minus 9 is negative 4, divided by 2 is negative 2. So that's correct because we have expected that the answers for this or the solution for this, we have two real roots or two unequal real roots. So there are two answers. We have the negative 2 and 7. So it says here that there are two unequal real roots if the discriminant is greater than 0. Okay, the next example we have x squared plus 2x minus 5 equals 0. So the value, let us solve first our discriminant. So we have delta is equal to b squared minus 4ac. And then we have the value of b is positive 2. So we have 2 squared minus 4 times the value of a is 1 from the coefficient of x squared times the value of c is negative 5. So our delta now will give 2 squared is 4 negative 4 times negative 5. 4 times 1 is 4. 4 times negative 5, we have positive 20. So we have 24. Since delta is greater than 0, our expected answer will be we have two unequal roots. Okay, just look at this. So greater than 0. So that is our expected answer. So let us continue to find the value of x. So using the formula now of quadratic formula, we have x equals negative b plus and minus the square root of delta all over 2a. So x equals, your b now is positive 2, the negative of positive 2 plus and minus the square root of delta, which is now the discriminant of b squared minus 4ac. So since we solved earlier to determine the kinds of roots, we have delta now equals 24 all over 2 times a. Your a there is still 1. So we have now the negative of 2 is negative. Negative times 2 is negative 2 plus and minus. Since square root of 24 is not a perfect square, so we can write square root of 24 in a simplest form. So the simplest form is we have 2 square root of 6 all over 2. Now, you can see that the coefficients here of the radical form is 2. We also have negative 2 on the first term, and we have a denominator of 2. Since they are common, this numerator is divisible by 2. So therefore, we can simplify that one. So we have now negative 2 divided by 2 is 1 or negative 1 plus and minus square root of 6 because 2 square root of 6 divided by 2, so we can cancel the 2 there, so therefore we have only the square root of 6. Now let us separate the two possible answers. We have negative 1 plus the square root of 6, and the other one we have negative 1 minus the square root of 6. If you want to know the approximate value, then take the square root of 6. But this one is the exact answers. So I will accept that one. In the last example, we have 3x squared plus 8x minus 2 is equal to 0. So find first a discriminant to determine what are the solutions for this. So we have b squared minus 4ac. So the b is the coefficient of x. So we have 8 squared minus 4 times the value of a is 3, which is now the coefficient of x squared. So 3 times the value of c is negative 2. So simplifying this one, 8 squared is 64. Negative 4 times 3 times negative 2. So positive. So positive 24. And then 24 plus 64 is 88. So still, the answer has two unequal roots. Okay? So by substitution now, x equals negative b plus minus the square root of the discriminant all over 2a. I just used their delta in order for me not to write very long, because it's quite long to write b squared minus 4ac. Okay, now let us substitute. We have x equals the negative of the value of b there is 8, so the negative of 8. Do not forget to enclose so that you will not be mistake in multiplying, or sometimes if the value of b is negative, so you forgot to multiply by negative sign. So we have now the negative of b, which is a negative of times 8, plus and minus the square root of delta, which is now 88, the value of delta, all over 2 times 3. So simplifying that one, we have negative 8 plus and minus. What is the simplification for the square root of 88? So it gives you now the answer of 2 times the square root of 22 all over 6. Now, as you can see, we have 2 square root of 22, negative 8, and 6. So these coefficients here, that can be reduced to the lowest term. Okay? So the lowest term is by 2. So we divide 2 each of these. Okay? So negative 8 by 2, we have negative 4 plus and minus. So divide this by 2, the remaining now is the square root of 22. So divide this by 2, the remaining is 3. So we have now the answer of x equals negative 4 plus and minus the square root of 22 over 3. Or if you like, you can write here x sub 1 equals negative 4 plus the square root of 22 over 3. And the other one is negative 4 minus the square root of 22 over 3. If you like to take the approximate value, then you can.